Hey everyone, and once again we're back together. All right, so today we're going to be looking at mathematics paper 2 for the IEB. Right, this was written in November 2023. All right, so if you haven't subscribed, do the right thing and follow your favorite uncle. Okay, right. Otherwise, I hope that for you who've written paper 1, that you wrote paper 1 well. Right, let's get you ready for paper 2. Okay, let's go right into it. Okay, so the first section, section A, they say to us in question 1, the percentage results obtained by 26 learners in a mathematics test is displayed in the box and whisker plot below. Now, of course, you know that I've already curated some content on statistics, right, on the box and whisker plot. Right, they say to us if the range of the data is 80, and the interquartile range is 80 and the interquartile range is 30, they say determine the value of A. Right, now remember that they've given us the range, and what is the range? It's going to be the maximum minus the minimum value. So 95 minus A would give us that range, which is 80. So we can write that down and say, well, 95 minus A would give us 80. And so that means that our A value would be 95 minus 80. And you can see how that will give us 15. So A is 15. And when we go to B, right, how do we find the value for B? They've given us the interquartile range. And please remember, the interquartile range, remember, this is going to be Q1. This is Q2, the median, right? And in this case, this is going to be Q3, right? And the interquartile range in this case would be Q3 minus Q2, okay, minus Q1 rather, and that gives us IQR, right? So we know that Q3 is B and Q1 is 40. And our interquartile range is 30. So that means that the value of B is 70. So we know that this value, there it is over there, right? B is equal to 70, right? So they said determine, in B, they say determine whether the minimum result obtained using your answer in A1 is an outlier or not. Use the formula Q1 minus 1.5 times IQR. Now we already have Q1, right? We said our Q1 value is 40 minus 1.5 multiplied by the interquartile range. And remember, we said our interquartile range was 30. Right, so 40 minus 1.5 times 30, that's 40 minus 45. Right, so that will give us negative 5. So that will give us negative 5. But remember, what is our minimum value? Our minimum value was A, which is 15. So since our minimum value is much greater than negative 5, therefore it means that that minimum value is actually an outlier. So yes, it is an outlier, right? An outlier. Right, let's go to the next one, ladies and gents. Right, so they say the table illustrates the approximate time spent in minutes, right, by 7 learners studying for a mathematics test and their marks obtained as a percentage, right? So they say to us, okay, there's that table. They say predict using the equation of the least square regression line in the form of y is equals to a plus bx for this data. What mark a learner who studies 180 minutes would obtain. Now, ladies and gents, let's use our calculator. You know, usually you'd go to mode, right? You choose the stat function on your calculator, right? Just like I'm doing here. And in this case, you would go to the a plus bx option. I think it's usually option 4. I don't quite remember on your calculator, but I'm using this one. So let's put in the data. So we've got, firstly on our x values, 0, right? Remember, every time you put in your data, you have to press equal to. The second one is 90. The next one is 90. Next one is 80. The next one was 90 as well. The next one is 120. And the last one is 150. All right, now let's put in our y data. So that's going to be 15. That's 59. That's their max. That's 60. That's 73. Okay, we've got 85. We've got 90 as well as 95. Right, so this is all our data. So now what we're going to do, ladies and gents, is we are going to work out the least square regression line. You'd press shift and you go to number 1 on stat, right? So you can see there, I've got different options, right? I will say regression calculation. Of course, on your one, you would have that option as well. So my A value, so my graph says this is y is equals to a plus bx. My A value is 19.2, let's say 19.2. In fact, they did say that round your answer to 3 decimal places. So I'll keep, I'll say 259. Okay, I'll say 0.551. Okay, times x. So that's in the form y is equals, in fact, that would be 552, right? So 552 times x. All right, now they said to us we need to find out, right, what will be the mark obtained by a learner studying 480 minutes. So what I'm going to do is I'm going to replace there. I'm going to substitute 180 for x, 259, plus 0.552 multiplied by 180. Okay, let's see what you get there. And our R value is 0.93. Okay, I don't know if we're going to need it, but let's see. Right, so firstly, let me calculate there. I've got 19.259. I wrote 252 there for some reason. Okay, 259 plus 0.552 multiplied by 180. And in this case, I get a value 118. 118.619. Okay, that's 619. Okay, so that's the value that I'd get. Oh, that's over 100%, ladies and gents, right? And they say, is the prediction in C1 a reliable one? And you need to explain. Well, I don't think so. No, it wouldn't be a reliable one, right? Firstly, you can't get a mark that is more than 100%. Okay, so what it implies, right? So it implies that a learner studying for over 100, for over 180, for 180 minutes would obtain a value greater, or rather 100% or more, right? Okay, and in this case, please note that 180 would be outside of the range of your data, right? So it basically is an extrapolation, right? So we are extrapolating in this case. And in this case, please do note that you cannot get marks that are greater than 100%. Okay, so it definitely is not reliable. All right. Okay, so let's go to the next section. with question 2. So they say to us in the diagram, we've got ABCD, which is a trapezium with AD parallel to BC and BCD equal to 90. Now they've given us the points there, which are A, B, C, and there it is on the diagram. Right, so let's quickly have a look at this one. So they say determine the gradient of BC. Now if we look at BC, we know the gradient of the line BC would be equal to, that's y2 minus y1 divided by x2 minus x1. Okay, I'll take the values of C as my second point. So I'm going to say this is 7 minus 4 divided by 6 minus 0. Okay, so 7 minus 4 gives us 3, and 6 minus 0 gives us 6, and so our value becomes 1 over 2. All right, so that is the gradient for BC. Now they say determine the equation of the line CD. Now you'll see that CD and BC are perpendicular to each other. So we know that the gradient of CD and multiplied by the gradient of BC, that would give us a -1. So we already know that the gradient of CD should be equal to -2. It's the inverse of BC with a different sign. So that's -2. So we already know that CD would have the equation y is equals to -2x plus c, but we've got a point at C which is 6 and 7. When x is 6 units, y is 7. So in this case, we know that y is 7. We substitute it there. That's -2 times 6. That's plus c. And if I take -2 times 6, that would give me -12. To the other side, c becomes 19. And so my equation would be y is -2x plus 19. All right, and we move on to the next portion. They say determine the equation of AD, hence the coordinates of D. Now if you'd note there, AD is parallel to BC. We already said that the gradient of BC is a half, so meaning that the gradient of AD would also be equal to a half. But we've got the point A, which is 4 and 1, right? So the equation of AD, okay, let me say the gradient of AD is equal to the gradient of BC, and we said that's 1 over 2. And in this case, we said, all right, so it means the equation will be 1 over 2x plus c. So we said we're going to substitute the point at A, which is 4 and 1. So when y is 1, x is 4, okay, plus c. Half of 4 gives us 2. And if we take that to the other side, it becomes -2 plus 1. And so our c value becomes -1. So the equation of the line AD would be y is equals to 1 over 2x minus 1. Now remember, to find the point D, what's happening at D? The two lines CD and AD are intersecting there, right? So let's do this. Let's equate the equation of CD, which we do know now is -2x plus 19, and the equation of AD, so which means -2x plus 19 would be equal to 1 over 2x minus 1. Right, I'm going to take the half x to the other side, so that will be -2x minus a half x, so that will give us -2.5x, and I take the 19 to the other side, that will be -1 minus 19, so that will be -20. Okay, and if I divide both sides by -2.5, All right, so that will give us x is equal to 8, I believe. So in that case, x is 8. Now I'm going to substitute that into the equation of AD. So for my y value, I'm going to say this is half of 8 minus 1. And so half of 8 is 4 minus 1. That gives us 3. So I can go and put that in my equation. So D would be the point 8 and 3. X is 8 and y is 3. Okay. Right, we got both positive values, so it does verify that we must be correct. Okay, right, now they give us the next point. They say it is further given that point F is a point in the first quadrant, so that FEDA is a parallelogram. Now, if you note there, FE, it means that the line FE would be parallel to AD. Right, that means that FA is parallel to ED, right? And now they say to us the coordinates of D are 8 and 3. That's what we found. Right, so now they want us to determine the coordinates of F. All right, so we are going to look for the coordinates of that point there. Now, ladies and gents, what I'm going to simply do here is I'm going to, if that is a parallelogram, then it means that EA must be a diagonal to that parallelogram. Now note, if I'm going to draw another diagonal there, which is FD, right? What would we note about that diagonal? What do we know about the diagonals of a parallelogram? We know that the diagonals of a parallelogram are actually they bisect each other. So which means EA would be equal to, rather not EA, that means that, okay, if we call that point, whatever, let's call it P, right? So which means that FP, FP would be equals to PD. That means also EP would be equal to EA. It's the midpoint of both those diagonals, right? Now, already I've got another midpoint C of CA, right? So let's find point E. So what would be the point E there, right? So point E would be the midpoint of CA, right? So I'm going to take the x values, so that's 6 plus 4 divided by 2. So 6 plus 4 divided by 2. And for my y values, I'm going to say 7 plus 1 divided by 2. So what are the coordinates of E? That would be 6 plus 4 gives me 10. Divide by 2 gives us 5. And let's talk about the y value there. At 7 plus 1, which is 8, divided by 2, that gives us 4. So E is the point 5 and 4. So let's look for that midpoint P of the line EA. So I'm going to say, right, the midpoint P of that line would be, again, we're going to do the same thing. So I'm going to say 5 plus 4. So that's 5 plus 4 divided by 2. And what about the y value? That would be 4 plus 1 divided by 2. So, which means the midpoint P there would be the 0.5, 9 over 2, as well as 5 over 2. All right, so that would be my midpoint over there. But I know that midpoint P would also be the midpoint of the line FD, right? So now, if I take the x value of F plus the x value of D divided by 2, right? That should give me the x value at P, that midpoint, which is 9 over 2. Okay, so let's find the x value at f. And I'm going to do the same thing for the y value, right? So that means 8 plus, or xf plus 8 divided by 2 is equal to 9 over 2, right? So my denominators are the same. I can simply drop them down. So which means that xf would be equal to 9 minus 8, which is 1. Okay, so let's do the same for y values. Y at f, yd over 2, this would be equal to 5 over 2. I did say that we can drop those denominators in this case. We've got the same denominator, so that means yf plus, what's yd? That's 3. And this is equal to 5. And so which means the y value at f would be 5 minus 3, which would be equal to 2. So my coordinates for f must be 1 and 2. Now, ladies and gents, another way that you could have done that, you already know that AD is parallel to FE, and we know the gradient of AD, right? We calculated that to be a half. Okay, and we also know we would be able to get the gradient of ED, and that would be equal to the gradient of FA. So we can use those two gradients to be able to calculate the values, or rather the coordinates of f. Okay, right, so that's another way there. Right, and then finally, they say determine the angle EAD correct to 1 decimal place. Right, so let's look at that. So EAD, right, so that's EAD. So we are looking for this angle over here. Right, now we've got the line CA and we've got the line AD. We already know the gradient of the sky. Now, I want you guys to please see this. I'm going to try and draw it in a different color. If I just extend that line AD there, and I also extend the line CA, right, so if I do this, if I can find the gradient of the line AC, right, and now I can work out that angle there in red, right, and I can also find the gradient of the line which I already have, AD, which is a half, and so that would give me this gradient here. Now, this red angle, right, from the line AC would be an exterior angle of that triangle, right? So it would be an exterior angle of this triangle, which I'm going to show you in blue there, right? So it's an exterior angle of that triangle. And we know that the exterior angle of a triangle is equal to the sum of the opposite interior angle. Now, if I can get this angle, which I'm going to indicate in yellow, right? They make opposite, vertically opposite angles with that angle EAD. Okay, I hope that makes sense. So what I'm going to do is I'm going to determine the gradient of the line CA, right? So let's find the gradient of CA. By the way, there's nowhere where we had actually found that gradient, right? So I'm going to say, right, the gradient of CA, and find the gradient of, the angle of AD, right? So I'm going to say, right, the gradient, okay, let me just change color there. Right, the gradient of CA, okay, so let's take our values there. CA, that's 7 minus 1 and 6 over 4. Did we not find that gradient? Okay, so that's 7 minus 1, okay, divided by, 7 minus 1, y2 minus y1, divided by, so that's 7 minus that 1 divided by 6 minus 4. That's 6 minus 4. Okay, so 7 minus 1 gives us 6. So that will be 6 over 2, right? So remember, in this case, 6 minus 4 gives us 2. And so that's 6 over 2, which gives us 3. So the gradient of the line CA is 3. So let's say the tan of, let's call it beta, right, is equal to, right, 3. So let's find that exterior angle beta there, right? So that would be the arctan of 3, right? Help me out there. So we're going to say shift 10 of 3. So that's 71.5, well, let's just say 57, right? They said correct to the 1 decimal place. So let's just say 71.6 in this case. Right, so 71.6. And so what I'm going to do is now find the tan. Remember that line A, it's AD, right? We know the gradient is a half. So let's call it theta. Would be the arctan of the gradient of AD. Okay, so that's arctan of 1 over 2. And so the arctan of 1 over 2, let's find that quickly. Shift 10 of 1 over 2. And please remember, ladies and gents, you must make sure that your calculator is in degrees rather. 26.6. Okay, right, now that's the angle theta. Now remember what I said, that's an exterior angle, right? It would be equal to the sum of the opposite interior angles. So essentially, the angle EAD would be equal to 71.6 minus 26.6, right? And in this case, we can use the exterior angles on a triangle, all right? And in this case, that would be 71.6. Okay, so that's 71.6 minus 26.6. And I get that angle to be 45. I'm sure there's a myriad of other ways in which you could get that angle. All right, you can explore a little bit and see if you would be able to get that. Otherwise, I'm going to leave it there. Right, as we go to the next question, they say hence or otherwise determine the area of parallelogram ADEF. Okay, so now if we look at that parallelogram, so note, let me just remove, we just removed this guy here. Right, so they want the area of that parallelogram, right? So what I'm going to do, because I already know this angle here, right, 45 degrees. Now note in this case, if I can find the area of this triangle, right, EAD, then it means that the area of the parallelogram would be twice the area of that triangle, okay? Because remember, this area here would be equal to that area there. So what I'm going to do, ladies and gents, let me look for the length of AD. Let me look for the length of EA. And then I'm going to use the 45 as the included angle in that case. So let's find the length of AD first. So I'm going to say AD, right? Use my distance formula there. So AD, that's the square root of, right, that's x2 minus x1 squared plus y2 minus y1. Okay, so I'm going to take the coordinates of A and D. So my x coordinates, okay, that would be 8 minus 4 squared So that's square root of, okay, so I'm just trying to write that nicely. So that's square root of 8 minus 4 all squared plus, right, so for my y values, that's 3 minus 1 squared. Okay, so 8 minus 4, that's 4. 4 squared, in this case is 16. 16 plus 3 minus 1 would give us 2, right? So this would be the square root of 16 plus 2 squared is 4, right? So that would be the square root of 20, right? So the line AD is root 20 units, right? And then we look for the length of, we said AE, right? So that would be 5 minus 4 and 4 minus 1. Okay, so we'll say, right, square root of 5 minus 4 squared and 4 minus 1, that's the corresponding y values. Let's just make sure that we are correct there. Our x values are at 5 and 4. Yes, that's correct. Okay, and our y values, that's 4 and 1. Okay, so let's find that value there quickly. So 5 minus 4 gives us 1. Okay, so this will be the square root of 1 plus 4 minus 1 gives us 3. 3 squared is 9. So this would be the square root of 10. All right, so now we're going to say, right, the area of triangle AED, right, will be half EA times AD, right, the sine of angle EAD, right, so which gives us half of root 20 multiplied by root 10, the sine of 45 degrees. Okay, so let's try and get that quickly. So this would be 0.5 times the square root of 20 multiplied by the square root of 10, and this would be the sine of 45. All right, you can please verify if I am correct there. I get that area to be 5 square units, right? That's units squared. But remember, we're looking for the area of the parallelogram. So in this case, it means that the area of palm or parallelogram, right, ADEF would be equal to 2 multiplied by 5, and this would be equal to 10 square units. All right, so that is really how the cookie crumbles. All right, apologies for the little bit of an echo, right, in the room that I'm working in. There's a little bit of an echo, but otherwise I hope that you understood that. All right, we'll go to the next question. Question 3, they say the frequency polygon represents the results obtained by 27 learners in a mathematics test. They hopefully were writing my test. Okay, so they say the class intervals are given as 0 to 20, 20 to 40, and 40 to 60, and so on, right? Now, they've given us the frequency polygon there. Now, ladies and gents, I want you to be careful. Please, if you haven't watched my videos on stats, please have a look at them. Now, in a frequency polygon, I want you to always note that what they give you is, for the class intervals, they always will give you the midpoints, right, of your intervals. So if they've given me the interval 0 to 20, how I draw the frequency polygon is that I'll always take the midpoint. Now the midpoint here is 10, the midpoint there is 30, the midpoint there is 50, the midpoint there is 70, the midpoint there is 90. Okay, right, so those are the values that I am given over there, right? And now it tells me that in the interval 0 to 20, my frequency there would have been 1, right? In the interval 0 to 40, right? There, I'll read it at 30. My frequency there would have been 7. Okay, right. So that's how you read this graph. In the interval 40 to 60, I read it at 50. My frequency there would have been 10, right? In this case, that would be your, so that's where you've got the most number of learners. So in this case, from 60 to 80, I read it at 70, so that would be 5. And from 80 to 100, I read it at 90, and so that would be 4 over there. Right, now they say to us, determine the estimated mean of the set of results. Now remember, how do we find the estimated mean? Right, we are going to take the sum of the midpoint of our intervals, right, multiplied by the frequency, right? And in this case, so I'm going to say Fn, so Xn, Fn, right? Divided by, in this case, my population size, and we said it is actually 27 learners, right? So that would be, in this case, 27 of them. Right, now let's do that. So we're going to take the sum. So this is going to be 1, right? Okay, so firstly, we set the midpoint of the value. So 10 multiplied by, my frequency there is 1, okay, plus, this is going to be 30 multiplied by, we set it 30, the frequency is 7, plus we've got 50, our frequency is 10, so that's 50 times 10, plus we've got at 70, we've got 5, and the last one at 90, we've got 4. Okay, and this would be divided by the number that we have, which is 27. Okay, our accumulated frequency, right? So let's calculate that. So I'm going to say 10 times 1 plus 30 multiplied by 7 plus 50 times 10. Plus, please just make sure that I do the right thing there. 70 times 5 plus 90 times 4. Okay, so let's check that. So that's 10 times 1, 30 times 7 plus 50 times 10 plus 70 times 5 plus 90 times 4. Right, so that's my total there. And I'm going to divide by my cumulative frequency, meaning my total number of people. So in this case, my mean is sitting at 25.96. 25, let's just say, 53 rather, 52.96. Let's say 53, okay? So which means that my estimated mean would be at 53, right? Now, in this case, they say what percentage of learners obtained results in the interval 60 to 80. Now, remember, in my frequency polygon, I am actually going to get that from 60 to 80. I'm going to get that at the midpoint, which is 70. And how many learners would that be? That would be 5, right? So that would be 5. Now we want to work out a percentage, so that's 5 out of 27. And to make that a percentage, we multiply by 100. Okay, so we're going to say this is 5 divided by 27. This is multiplied by 100. And we get 18.5%. Right, so that was 18.5% of the learners that got 60 to 80. Okay, right, now they say use the information in the frequency polygon, right, to draw the cumulative frequency or curve, or the ogive, whatever you want to call it, that represents the results of this group of learners, right? All right, let's do that, ladies and gents. So remember, we said we had, in this case, from the interval, right, 0 to 20, right? Remember that when you are drawing the ogive, in this case, you're going to take, right, so in your, right, in the interval that you are given, you always take the uppercase or the upper class value, right? In this case, that will be your x value, and your frequency value then becomes your y. Okay, so which means in my case, at 20, I am going to have 1, all right? And then my next one would be at 40, right? What's the value at 40? I'm going to take my value, that's going to be 7. So at 40, I'm going to have 7, so that's 5, 6, 7, so at 40, I've got 7 over there, right? And then the next one, right, my upper class value, right, that's 60. So at 60, I am going to have, right, the midpoint there was 50, that's 10. So at 60, I am going to have 10. Okay, in fact, actually, I'm doing the wrong thing here, because remember, it's cumulative frequency, right? So I'm actually supposed to be adding. So at 20, I've got 1, right? At 40, I'm going to say plus the 7, right? So in this case, I've got the 1 plus the 7, which would give me 8. Apologies about that, ladies and gents. So that would be 8, okay? And at 60, that's going to be the 8 plus the 10, right? Which would give me 18. So that would give me 18 at 60. All right, so there we are. So there's 18 over there, right? So that is at 60. And then at 80, right, at 80, I am going to say plus the value there, which is 5. Okay, so I move 5 up. So at 80, I've got 18 plus 5. Okay, so there I am at 23. So I'm just trying to make sure that I'm accurate. 21, 22, there's 23 over there. And then finally, ladies and gents, at 100, I'm going to add the last value that we have, which is 4, right? And I should actually end up at 27, right? So that should be at 27 over there. Apologies for that initial confusion. Right, so in this case, we're going to try and put our S-curve together, right? And you remember what we always do is to always just extend it, right, to 0. Right, so this is what my S-curve would look like. Right, now in this case, let's go to the next question. They say to us, indicate on the horizontal axis of your cumulative frequency curve in C, right, where you would read off the median. There we go. Now remember, what is the median? That's 50%. It's a 50 percentile, right, of your data. So now, what I'm going to do, what's 50% of 27? Remember, the cumulative frequency. So in this case, it's 50% of 27, right? Now, what's 50% of 27? Divide that by 2. In that case, that's about, what, 13.5, right? So which means, let me just try to use a different color, right? So that's 10, that's 11, 12, 13, right? But it's at 13.5. So there's 13.5 over there. Okay, I'm going to try and just be as accurate as possible. All right, so let's bring the ruler down a little bit. Okay, so there is my 50 percentile. But now let's get the corresponding value, right? So that would be, okay, so that would be the corresponding value there, right, for my percentage in terms of marks. So that would be what? I think that's 52 or 51, shall we say? Yeah, that's definitely 51, right? Okay, so, and then, so let's say this is going to be our median. Okay, so that's our median value. And then they say to us, indicate where you would read off the values required to determine IQR, right, interquartile range. Now remember, that would be a 25 percentile, first of all. So I'm going to take 25% of 27, okay, a quarter of 27, all right, just to make sure that we are very accurate there. Okay, let me just remove the ruler. All right, so what's a quarter of 27? So 27 divided by 4, that's 6.75. Okay, so I'm going to go into my, all right, so there's 6 there. Okay, so 6.75 would be somewhere in between, more leaning towards 7. So I'm going to use, okay, right, there's my ruler doing some stuff there. Right, actually let me just remove that there. Okay, so that means, where is my 25 percentile? It would be this guy over here. So that means that would be my Q1 value. Okay, oh, and by the way, this is Q2, this is the median. Okay, and now let's find Q3, ladies and gents. That's the 75th percentile. So in this case, that's 75%. So let's go to our calculator again and say 0.75 of 27. Okay, or you can say 27 multiplied by 3 over 4. Or you can say just 27 times 75%, 75 over 100, right? So what do we get? We get 20.25, right? So I'm going to take that. Let's go to, so that's 20.25, let's say somewhere there. Okay, and that would be, okay, so there's my value. All right, now So which means this would be Q3, right? So we extend this here. Right, so that means this is your Q3. And remember, to calculate your interquartile range, you take the value there. I think that value would be almost 68, okay? And you can say that would be 68 minus the value at Q1, which was, let's say, 37, right? So that's how you would calculate your interquartile range. But they just wanted us to indicate it on the graph, not necessarily to calculate them. Okay, so I'm just showing you how you would be able to calculate that. And by the way, for the median, okay, so I made a mistake here. So this is our 75th percentile. All right, so we've indicated those values on the graph. We don't need to write anything there. Now they say to us, using your answer, okay, okay, so our answer in A, which was, what was our answer in A? Oh yes, that was the estimated mean, right? Okay, so our mean in this case, and then our mean was 53, right? Our mean was 53. And they say our answer in D1, which is the median. And remember, we found our median to be somewhere at 51 when we looked at it. Okay, so they say describe the skewness of the data. Right, so in this case, we realize, ladies and gents, that our mean is greater than, so our mean is greater than the median. And remember, every time that the mean is greater than the median, it means that our data is positively skewed. Okay, so that would be positively skewed data. Okay, I hope that makes sense, ladies and gents. All right, and that is where we will leave this question. Let's go to the next point. Let's go to question 5. Right, so we're given there that we've got, they say use the diagram below to prove the theorem that states that a line drawn parallel to one side of a triangle divides the other two sides proportionally. All right, so ladies and gents, this is really quite a simple, but it can be complicated if you don't know what you're doing. Proof, right? So in this case, what we're going to do is we're going to draw construction lines. And let's just announce that. So let's say we're going to construct the lines. So I'm going to construct line BE and line DC. Okay, so let's do that. So there's BE over there, and there is line DC. Okay. Right, now if you look at that, so we're going to now use our triangles, our area formula, right? So we're going to say the area, now please I want you to note, the area of triangle ADE, right, over the area of triangle, now I want you to note that smaller triangle there, which is DBE. Okay, so DBE. Right, now let's start with the area of triangle ADE. Right, so ADE, this would be half base. The base is AD. Right, so that's half the base, which is AD, multiplied by perpendicular height. Its perpendicular height is that guy FE there. So this is multiplied by FE. This is divided by half. Now we said we are looking at the triangle DBE, right? So this is going to be the half times. The base is going to be DB, right? But if you note in that triangle, the perpendicular height is still that height FE over there. So that's height FE, right? Now, if you notice there, we can cancel those two. Okay, and those two cancel, and what are we left with? We're left with AD over DB. DB rather. Okay, right. I'm going to take the area of ADE again. So the area of ADE, triangle ADE, right, over the area of the smaller triangle at DEC this time around. So we're looking at this guy over here, right? So let me just undo that. Okay, so DEC, and now this is going to be half off. Now note the base is going to be AE, and this is multiplied by the perpendicular height, and its perpendicular height is the line DG. That's DG, right? So divided by, okay, let me just write that nicely. Right, half, so we go to triangle DEC, right? The base in this case is going to be the line EC, and again, the perpendicular height cannot be the line DE, but it is the line DG again. So that is DG. All right, so once again, you've got those two canceling out, and so you've got AE divided by DB. Now, in this case, ladies and gents, I want you to note that, so we now have that as, okay, we can call this equation 1, and you can call that equation 2. But if you note, ladies and gents, that the area of those two smaller triangles, BDE, or we said DBE in this case, right, the two smaller triangles, those areas should be equal, right? Okay, so in this case, should be equal to the area of triangle, the area of triangle DEC, that smaller triangle as well. And why is that? Okay, remember that they've got the same base. Okay, so if you note there, their bases are equal. Let's say same base over there, right? So they've got their bases equal because they are between parallel lines, right? So that same base between parallel lines, okay? So that's the reason there. And so now if you think about it, ladies and gents, of course, on the top part, you did have ADE, so we've got triangle ADE, it's the same triangle, but we found out that triangle DBE is equal to DEC, and so therefore we can say that equation 1 is equal to equation 2. So AD over DB would be equal to AE over DB. Sorry, that was supposed to be EC. Apologies about that. So AE over EC. All right, and that is really how we prove that there. And we are done. Let's go to the next part. So they say in the diagram, we've got HIJ, which is a right angled triangle, right at I. They say L lies on IJ such that JL is 9 units. LI is 12 units, and they say K lies on HI with KL parallel to HJ. Okay, we can see all of that. Right, now they say determine the length of IK. So this is where we want to go, ladies and gents. Now there are two different ways in which we could do this, right? I don't know which one you would like. So what we could do is we could find the length of HI, right? Using the Pythagorean theorem, we know the length of IJ, we know the length of HJ. So we can say HI squared is equal to hj squared minus ij squared. Remember, the hypotenuse in this case would be hj, right? Now note in this case we're looking for hi, so this would be the square root of, now hj is 29, that's given as 29 squared, minus the length ij would be 12 plus 9, right? Now note in this case that would give us 21, right? So in this case this would be 21 squared. Okay. Right, so let's find out what that gives us. So we'll take that entire, that's the square root of 29 squared minus 21 squared. Well, that gives us 20. So which means the length hj would be actually equal to 20 units, right? But now remember that we've got a ratio over there, right? So which means if I take IL over ij, right, this would be ki over hi, right? So let's write that down. So this is going to be ij over, no, not ij, rather, we said il over ij. This should be equal to ik over hi. All right, and remember we need to give a reason for that. Sorry, I don't have enough space. So in this case, this is exactly what we said. We said a line that is parallel to the third side of a triangle, all right, divides those sides proportionally. So this would be the proportionality theorem. Or you can simply state that line parallel to the third side of a triangle. Right, so in this case, I know that IL is 12. Right, ij, we said that's 21, right? The length, the total length there, that's 12 plus 9. And then ik is what we are looking for, divided by hi, we just found that to be 20 units. All right, so let's work out the value of ik. So cross multiplying. So ik would be equal to, that's 12 multiplied by 20, those two multiplied by each other and divide by 21. So let's find that answer quickly. So that's 12 times 20, okay, divided by 21. I get that to be 80 over 7. Okay, I hope that makes perfect sense. Right, so that would be the units there. They didn't say that we must leave it in whatever decimals, so I'm just going to leave it as a fraction. I hope that makes sense, ladies and gents. And essentially that's how we get the length of ik. All right, and that's how the cookie crumbles. Let's go to the next part of this question. To question 4. They say in the diagram we've got points A, B, and C that all lie on the circle with center O. Now I see I've got center O, and I always say that, you know, when I see a center, I want to mark out all the radii. So that means OB would be equal to OC would be equal to OA. Right, those are important for me because sometimes you can find that we've got isosceles triangles, right? So they say to us line OA is parallel to CB. Okay, they've indicated it there. And they say OAC is 25 degrees. Now, they want us to determine the angle COA first, right? So that's COA. Now notice, ladies and gents, OA is equal to OC. So OA is equals to OC, and because they are radii, all right? And so that means that triangle OAC is isosceles, right? So therefore it means that angle O1, or rather angle A is equal to angle C1. So A1, rather angle A is equal to C1, which is equal to 25 degrees, right? Why is that? That's angles opposite equal sides, or you can say they are the base angles of an isosceles triangle, right? And so as a result, you see why it's important for you to realize that you've got radii, right? And so what that means, if I go to triangle OAC, so therefore it means that angle COA, so COA would be equal to 180 minus those two angles being 25 degrees, right? So that's 180 minus 2 times 25, okay? This is the third angle of on a triangle, so which means that COA is equal to 130, right? So I'm going to say this is third angle on a triangle. All right, so we've got that COA there. Right, so that guy is 130 degrees, right? The whole of that angle. Now they want us to find angle O1, okay? So let's see. All right, so angle at center twice angle at circumference. I already know this guy is 25 degrees. Now notice, ladies and gents, that if I look at O1, right, we've already said that that angle is 25 degrees. But notice, we've got alternating angles. C2 should also be 25 degrees, right? So I'm going to start there. I'm going to say angle C2 is equal to angle A, right, which is 25 degrees. That's alternating angles, right? Already given that those lines are parallel. So now I want us to note, ladies and gents, that means that angle O2, right? Please, I want you to note angle at center O2 would be the angle at the center, right? And C2 would be the angle at circumference, right? Remember, both of them are subtended by chord AB, right? So angle at center twice angle at circumference. So I'm going to say, well, it means that O2 would be equal to 2 times C2, okay, which means O2 is 50 degrees, and the reason is angle at center equals to 2 times angle at circumference, okay, right? And so to get O1 rather, we said O1 plus O2, in that case that gave us COA, which is 130. So O1 plus O2 is COA, right, is equal to 130. And so that means that O1 will be equal to 130 minus 50. And in this case, that would give us, so what's 130 minus 50? That would give us 80 degrees. Okay, so that angle would be equal to 80 degrees. that would be the value of 01. And ladies and gents, would have earned ourselves 5 marks out of that. Let's go to the next question. Question 6. So they say given f of x is sine 2x and g of x is cos of x plus 45. This is for x is an element of negative 90 to 180. They say sketch the graphs of f and g on the same set of axes below. Label all intercepts with axes, turning points, and endpoints. All right, ladies and gents, let's first look at this. So we've got the graph of sine of 2x. Now remember, if our frequency is 2, then it means that the period of the graph, right, would be 360 divided by 2. So which means we would be able to draw a complete sine graph within a 180 period, right? Now remember, what does the sine graph look like? Okay, so we know it's a graph that would look like that. So in this case, it means, the step of your graph would be half the original. In this case, so I'm going to just simply say, so it means that I'm going to have a normal sine graph at 0. This is going to be 0, right? So at 90, it was supposed to be 1, but that's going to happen now at the half of 90. Okay, in this case, it's going to be at 180, it was supposed to be 0 again, but now it's going to happen at the half of 180 and the half of 270, okay, and 180, right? But the same is true also on this side and on that. So I'm just going to draw that graph there. Okay, so there. Okay, so let me just redraw that quickly. I was coming very nicely with it. Okay, and apologies for that squiggly line there. Right, I'm trying to keep my hand as steady as possible. Right, so we're going to show our turning points. So this would be 135. Okay, so for some reason this is not cooperating. So 135 and negative 1. So this would be 180 and 0. Okay, and this would be negative 90 and 0, as well as negative 45 and negative 1, as well as 45 and 1. Okay, that's what our graph looks like. So those are all the turning points. They said we should also label, right, x-intercepts. So the intercepts, so here we've got 0 and 0. Okay, and we've got 90 and 0. Okay, yeah, so there we have it. Right, so let's go to the next graph. So the graph of cos of x plus 45. I'm going to draw that in a different color. So this would be the graph of g. So now, ladies and gents, which means we've got the normal cos graph, but we've shifted it 45 units to the left, okay? So remember that's plus 45, so that means I would have shifted it 45 units to the left. So what I'm going to do, what we can do is say, well, what would be at negative 90? So you'd say cos of negative 90, right, plus that 45. Can you see we get 0.70? So which means our graph would start somewhere, let's say 0.7 is somewhere over there. Okay, right, let's say somewhere there, right? And you'd note there at negative 45, right, it would be negative 45 plus 45, which means that would be 0. We know that cos of 0 would be 1. Okay, so let me just bring that slightly lower. Okay, and now at 45, I can almost see what the graph is going to do. Right, at 0, it's going to be cos of 45, which again is root 2 over 2. Right, now at cos 45, this is the same as cos 90, right? And cos 90, we know that this would be 0, right? And note in this case, okay, at 90, so what's 90 plus 45? Okay, that's negative 0.70. So in this case at 90, we're going to have negative 0.707. So let's say somewhere there. Okay. And at 135, so this would be cos of 180. So that would be minus 1, right? And I can imagine that at 180, we'd have something like this. So what would our graph look like? So we'd have a graph that looks like this. Okay, and right. So there we go. So I know that I didn't draw that very nicely at that turning point, right? So which means the two graphs intersect at 135. Okay. Right, so now let's go to the next point. So they say determine the values of x, right, where f of x is equal to g of x. All right, now they said we should calculate that. So f of x equal to g of x. So in this case, we've got f of x equal to g of x. So which means the sine of 2x equal to cos of 45. This was x plus 45, right? So that's x plus 45. Right. Now, ladies and gents, I've got sine and cos on either side. So what I'm going to do is I'm going to convert both of them to cos and cos. So you remember that the cos of 90 minus 2x would be equal to the sine of 2x, right? So I've changed nothing about that. So that's x plus 45. Now, we've got the same trig ratio on either side. So which means our angles are equal. So this would be 90 minus 2x is equal to x plus or minus, right? Remember, whenever you find the solution for cos, we always say plus or minus for it, right? This is plus k 360, where k is an element of integers. Right, nothing wrong if you use n. Okay, you can use any of those expressions. So this would be 90 minus 2x is equal to x plus 45. Or we've got 90 minus 2x equal to minus x, right? If I multiply by the negative, I'll have minus x minus 45. Ladies and gents, let's try to get to the answer there. So I will have negative 3x equal to, if I take the 90 to the other side, it would be 45 minus 90, which is minus 45, right? We said plus k 360. All right, this is plus k 360. And now divide both sides by negative 3. Okay, so we've got x is equal to 15, right? But now plus k, remember that 360 divided by 3 will give us 120, right? Or let's look at the next one. We've got, if I bring the x to the other side, I've got minus 2x plus x, which gives me minus x. If I take the 90 to the other side, it will be minus 45 minus 90, which is minus 135, right, plus k 360. And so x is equal to 135 plus k 360. Right, now they said I must look for the solution between negative 90 and 180. You can already see that this graph intersected at 2 points. So this must be 15, right? So which means x would be equal to 15 and x is equal to 135. Okay, so we are looking for those x values over there. They said, they said we must determine only the values of x. Right, so the next question, they say to us, use your graph to determine the values of x, right, between negative 90 and 180, for which f of x is greater than g of x. Now, if we note that, ladies and gents, let's find where the blue graph, right, f of x, is above the red graph. You can see it is from the point they intersect there. So the blue graph starts becoming above all the way up until they meet again at 135. So x is an element of 15, right? So remember they intersected at 15 there all the way till 135. So I can say, well, x is an element of, now remember they said greater than or equal to, so I'm going to say 15 included because they are equal there, all the way up until 135. Again, they are equal at that point, so I'm going to include it. You can also express it as x is less than 135, less than or equal to 135, it is greater than or equal to 15. Right, and then they say, where's the product of the two graphs less than 0? So essentially, we want where we take the y value of this multiplied by the y value of that graph, it should give us a value that is less than 0. Now remember, that can only happen if the signs are different, ladies and gents. So it means I'm looking for x values where the two graphs are either the one is positive and the other is negative, right? I can see from negative 90, the red graph is positive there, right? And the blue graph is negative, right? So that would be up until we get to 0 for this graph, right? For the blue graph. This one was negative and the other was positive. Then they both become positive, right? And then this would be now from 45 again. The red graph becomes negative. The blue graphs becomes positive there up until we get to 90, right? And then they start becoming positive, negative, both of them, right? So that will be x is an element of, right? Note in this case, we said between negative 90 all the way till 0. So that's the first one. X is an element of negative 90. So they said less than, right? Actually, negative 90 is included because they are not equal at that point. Right, so that's negative 90 all the way up until 0. Okay, excluded. 0 is excluded because they start becoming 0 there. Actually, at negative 90, that would be excluded as well because so that both of these values are excluded. Okay, because it would give us a 0 at negative 90 as well as at 0, right? Also, where is that graph? So that would be between 45 and 90 degrees, we said. So this would be from 45. Okay, I've gone too far now. Between 45, right, and 90 degrees. Okay, so or you can say that x is less than 0, greater than negative 90, right? Or x is less than 90 and greater than 45. Okay, note that the y values for the two graphs there are actually different, the one positive and the one negative. All right, so we leave it there for this question. Let's go to the next one. Section B, question 7. Let's go, ladies and gents. So they say ABD is a semicircle with center O. All right, so let's look at that. So center O, and they say to us we've got CB, which is a tangent to the semicircle at B. Right, so remember you've got tangent as well as diameter. So that would definitely be perpendicular, right? That's the 10 radius theorem. Okay, so they say OB is equals to 7 units. So that's the radius of that circle. It means that also AO should be 7 units in that case, right? Okay, they are radii. And so they say determine the length of CD correct to 1 decimal place. Right, now we're looking for the length of CD. Okay, now note in this case, ladies and gents, we're looking for that small little angle there. Side rather. So what we're going to do is I am actually going to construct. Okay, in fact, let's do this. Let's find AC first. Right, so in triangle ABC. So in triangle ABC, right, I am going to say, right, if you look at that, angle ABC, or rather angle B will be equal to 90 degrees. That's angle at semicircle. Okay, now in that case it means if I'm going to find AC, this will be my hypotenuse, right? So that's the hypotenuse, and this side would be the adjacent side, right? So I'm going to say therefore the cos of 38 degrees would be equal to, now please note in this case, adjacent, which is AB, over the hypotenuse, which is AC. So let's find the length of AC. So if we cross multiply, that means that AC will be equal to AB over the cos of 38. Okay, so I'm going to say AB is 14 units, right? So in that case, that's our diameter. Okay, this is divided by the cos of 38. Right, so I'm going to calculate that quickly. Right, so let's find that. So that's 14 divided by the cos of 38. That's 17.8. Okay, so I'm going to say that's 17.8 units, right? Now, I want you to note, ladies and gents, we are looking for the length of CD. So what I'm going to do next is that I'm going to just make a construction there of line DB, right? Now, if I make a construction of line DB, note this is also going to make a 90-degree angle, right? That's angle at semicircle. Actually, I said semicircle there, but it's actually not angle at semicircle. It is the 10 perpendicular to radius, right? That's 10 perpendicular to radius. Apologies about that. Right, so now this is going to form triangle ADB, which is a 90-degree triangle, right? So I'm going to say construct. So let's construct line DB. Line DB. Right, now that means that angle ADB, so angle ADB would be equal to 90. And the reason for that now is that this is the angle at semicircle. Okay, right. So in this case, that means that I can once again use my trig ratios, right? So if I look at that triangle, right, now AB becomes my hypotenuse in that triangle, right? Which means AD is now my adjacent side. Okay, so that means, right, the cos, once again, of 38 degrees is equal to adjacent, which is AD, over the hypotenuse, which is AB, right? In that triangle, that 90-degree triangle. Right, now I'm going to look for AD. So AD is equals to AB cos of 38. Right, and what does that give us? That's going to be 7 plus 7 units, which is 14 cos of 38 degrees. Right. So that's 14, the cosine of 38. So that's 11 point, that, well, we'll just say that's 11, right? That's 11 units. Okay. So if we're looking for CD, so which means that CD, right, will be equal to AC minus AD. And so our AC value was 17.8, and we're going to subtract 11 units, and so that means in this case that's going to give us 6.8 units. All right, and you could have chosen to round off at the end, and nothing wrong with that, but we would get more or less the same answer. All right, and that is how the cookie crumbles in this question. That's out of 7 marks. Let's go to the next one. Let's go to question 8. They say cos of theta is given by a squared minus b squared over a squared plus b squared. This is where b rather is greater than 0 and less than a. And they say sine of theta is less than 0. All right. They say determine tan theta in terms of A and B. Now, ladies and gents, let's do this, all right? So let's try to have an expression. So they said to us, we've got A squared minus B squared, okay? And we've got, okay, so let's say cos of theta. Now, cos of theta, I would assume that it would be positive in that case, right? So where is cos positive? It would be in the first quadrant, but it is also positive in the fourth quadrant, right? So in that case, I'm going to say, right, but they said that also sine theta should be less than 0. Now, sine theta is less than 0 in the fourth quadrant, so which means this is going to actually be, okay, oops, I just made an error there. Okay, so this is going to be, actually our triangle is going to be in the fourth quadrant, right? So I'm trying to draw that triangle there, so which means there's our triangle right over there. Now they're telling us what is cos? Cos is x over r, right? So our x there is a squared minus b squared, right? Our r, right, is a squared plus b squared. Okay, now we can find out what the value of x is, value of y is, right? So they said to us, okay, so let's write that down in the blue that we've been using. So we know that x squared plus y squared is equal to r squared. That's Pythagoras, right? But what do we have in this case? Our x value, right, is a squared minus b squared, right? That's our x value, that's squared, plus our y squared is what we are looking for, but our r squared is a squared plus b squared. And remember, ladies and gents, that this is squared, right? Now to get the value of y, so I'm going to say y squared. Right, if you wanted to, so this would be a4 minus 2a squared b squared plus b to the power 4 plus y squared, okay, and which is equal to a to the power 4 plus 2 a squared b squared, right, and this is plus b to the power 4. All right, so in this case, let's find the value of y squared. So I can see, actually this was supposed to be b to the power 4. So I can see this will cancel that, b4 cancels with that. Okay, and so what am I left with? I've got y squared is equal to, if I add those up, that would be 4a squared b squared. And so y, right, would be equal to, now note, ladies and gents, if I take the square root there, this will be 2ab. Okay, right, so that would be plus minus, but remember we're in the fourth quadrant, so this would be minus 2ab over there. Right, now ladies and gents, they said we need to find the tan of theta. So remember, tan of theta, that would be equal to y over x. Right, so let's do that. So we're going to say 2 minus 2ab, that's y. So that's minus 2ab divided by, okay, our x value, that's a squared minus b squared. All right, and that is really how the cookie crumbles. They said b is less than a. All right, so does that say anything to us? Well, not really. So this is really what our answer will be. There's no way that we can simplify that any further. All right, so that is where we are going to leave that one. Right, and then they say if it is further given that a is equal to 3 and b is equal to 2, solve for theta, where theta is an element of 0 to 720. Right, so now, okay, so they said a is 3 and b is 2. Right, now I'm going to go back to what I was given there. Right, so we said the tan of theta, actually we can even use that cos of theta there, it really doesn't matter. Okay, so let's say tan of theta, okay, is equal to, we said this is minus 2ab, so that's minus 2 times a is 3, b is 2, divided by, please note ladies and gents, we said a squared minus b squared, so that's going to be a squared minus b squared. Okay, and in this case, what do we get? We get negative 2 times 3 times 2, that will give us, that's negative 12, and in the denominator we've got 9 minus 4, which is 5, right? Now they said we should get the value of theta. Okay, so theta would be the arctan right, of negative 12 over 5. Right, ladies and gents, remember that's in the fourth quadrant, and we know definitely 10 should be negative there, right? Now remember, this is plus k 180, right? So let's find that angle there. Okay, so we're going to say this is going to be the arctan of negative 12 divided by 5. Okay, so that gives us negative 67.38 or negative 67.4. Okay, so that's minus 67.4 plus k 180. Right, whenever we solve for 10, okay, and this is where k is an element of integers. We should never forget to state that, right? Now they said we should find the solution between 0 to 720. So remember, to do that, you must now substitute for your value of k. You're going to start from 0, right? 1, negative 1, 2, and negative 2. In this case, I'm not going to bother myself with the negative integers, right? Because in this case, they would give me negative answers. I'm only looking for positive, right? So I'm going to substitute k is equal to 1, k is equal to 2, k is equal to 3 if it is not out of range. Right, so theta, in this case, if I say k is equal to 1, okay, let's check it. So that means we're going to have negative 67.4, right, plus 180 times 1. Okay, so that would give us 112.6. So that does fall between 0 and 1 and 720, right? Let's put, if we say, right, times 2, if we say k is 2, I get theta is equal to 292.6. If I say times 3, right, that would be 472.6. Right, let's see if 4 is within range. That's still definitely within range. So that's 652.6, right? If we put 5 there, okay, now it is 832, and that's definitely less than 720. So those are all the solutions for theta. So I'm going to say theta is equal to, in ascending order, 112.6, right, 292.6, 472.6, and finally we said 652.6. Okay, those are our solutions. Right, and we move on, ladies and gents. We go to question 9. So we must simplify the following into an expression containing only one trigonometric ratio of theta. All right, so let's do that. So we're going to have, this is going to be 1 over 2. Now cos of 90, now remember you are going to use your cast rule, right? So we know our cast rule, right? Cos of 90 plus theta. This is going to be in the second quadrant. How is cos in the second quadrant? That's going to be negative. So that's minus. But remember, every time you've got 90, you change, in this case, to a co-ratio, isn't it? So that's minus sine of theta, right? Okay, that's minus the sine of theta. Okay, right, now we've got sine of theta minus 90, right? Remember, you always add 360 if you've got a negative reference there. So that is going to be 360 minus 90, that gives you 270, and so that will be 270 plus theta. that should be in the fourth quadrant, right? 270 plus theta is in the fourth quadrant. Okay, so remember that will change, this guy will change into the sine of theta plus 270, or 270 plus theta, right? In this case. So that would be in the fourth quadrant. As I said, in the fourth quadrant, we know that sine is negative. So this will be times negative. Now remember, we're going to change into cosine in that case, right? Because we've got 270 and 90 there, right? So this is divided by the cos squared of 180. Again, let's check. Cos of 180, that would be in the 180 minus rather. That would be in the second quadrant. Cos is negative. So this would be negative cos theta. But remember, this is squared, right? Okay, so that's minus 2 cos of minus theta. So if we've got a negative angle, we add 360. So this will be 360 minus theta, right? So 360 minus theta, that's in the fourth quadrant, right? So we know that cos is positive there. So that would be minus 2 times the cos of theta, right? Plus, again, we've got cos of 90 plus there, which would be the sine. But remember, this changes to sine of theta. Sine is, cos is negative in the second quadrant, right? So this would be in the second quadrant. So cos is negative there, right? So this would be negative, but remember, it changes to its co-ratio. So that's negative sine of theta all squared, right? All right, so let's try and simplify that. So we've got minus half the sine of theta, 1 over 2, the sine of theta. That's plus sine theta, cos theta. And the reason why it's plus, it's because we've got a negative times a negative there, right? So this is divided by, if we look at that, we've got cos squared of theta, right? Minus 2 cos of theta plus the sine squared of theta. Can already see that that will give us 1. That's an identity. So I'm going to take out sine of theta at the top there. So I'm going to say sine of theta, which would be, so this would give us negative 1 over 2, okay, plus cos of theta. Right, so this is divided by, we've got 1 minus 2 cos of theta. Remember, we said sine squared of theta plus cos squared of theta gives us 1. All right, ladies and gents, now how am I going to solve this? Right? If I can multiply, now please, I want you to listen very carefully, right? So if I can multiply, look at the what I have at the bottom there. In fact, if I can multiply by 2 at the top, right? Multiply by negative 2. But remember, what I need to do is what I do at the top, I do at the bottom, right? Times negative 2 over there. Right? So what do I now have? Right, I'm going to leave this negative 2 here, but I'm going to multiply this negative 2 to those guys over there. Remember, in that case, I would have changed absolutely nothing, right? So I'm going to say this is sine of theta, right, into negative 2 times negative a half gives me 1, right? Negative 2 times positive cos theta gives me minus the cos of theta. Okay, And the reason I saw that, ladies and gents, so I still have the negative 2 there, multiplied into 1 minus the 1 minus 2 cos of theta. Now if I realize that, then it means that this guy is going to cancel. Okay, all right, this thing is misbehaving, right? So this guy is going to cancel that guy over there. And so what will I have? I will have sine of theta, or rather I can say negative sine theta over 2, or you can say this is going to be minus 1 over 2 the sine of theta. All right, I hope that makes sense. Right, so let's go to the next portion. They say we need to prove the following identity, right? Sine of theta, tan of theta, okay, is over 10 to theta multiplied by 1 minus 10 squared of theta equal to sine theta over 2. Now, ladies and gents, I always say we need to work on the left-hand side or the right-hand side separately. I'm going to start on the left-hand side, right? So I know my right-hand side would remain exactly as is. I'm going to leave it like that. Nothing to change there. The first thing that you always do is try to remove, change everything into sine and cos. So that will be sine theta multiplied by sine theta over cos of theta, right? And this is divide by, then I take that tan 2 theta, I'm going to say this is sine 2 theta over the cos of 2 theta. All right, and this is multiplied by 1 minus, again, the same thing, I've got 10, in this case that becomes sine squared of theta over cos squared of theta. Right, now let's try and work through that. Right, we're going to take it as slowly as we need to in this case. Right, now, if I look at those fractions, guys, it is a bit of a workout in this case. So I've got at the numerator, now please I want you to note. So I will have sine squared of theta divided by cos of theta. Now, in the denominator, ladies and gents, right? So, if I notice that, so I've got cos squared of theta over there in that denominator. So to try and make things just slightly simpler for myself, right? What if we multiplied both the numerator and the denominator by cos squared of theta, right? So multiply the denominator by cos squared of theta, right? Let me show you what that is going to do, right? So what it does is that now this cos here cancels out one of the cos's there. So instead of writing that entire thing, right, I will have sine squared of theta, right, multiplied by cos of theta. Right, just allow me to do that for now. Right, now the cos squared of theta, I'm going to multiply into this bracket. So what I'm going to have is sine theta, sine 2 theta over cos 2 theta into, now cos squared of theta times 1 gives me cos squared of theta, all right, and cos squared of theta times sine squared over cos squared of theta. Look at what happens. This guy would cancel with that guy, so I'll be left with minus sine squared of theta. All right, I'm sure you can see that identity there. Right, so at the numerator, I'm still left with sine squared of theta, cos of theta, divide by, now this guy, right, cos squared of theta minus sine squared of theta, that is cos 2 theta. So that is sine 2 theta divided by cos 2 theta multiplied by, that's cos 2 theta. And in this case, this guy cancels with that guy over there, right? So I'm left with sine 2 theta in the denominator. So now I've got sine square of theta in the numerator, cos theta divided by, right, sine of 2 theta, this is 2 sine theta cos theta. So this guy cancels with that, right? The sine cancels one of the sines there. And again, I'm left with sine theta over 2. All right, so in this case, what do you note? My left-hand side is definitely equal to the right-hand side. All right, I hope that has been helpful, ladies and gents. Right, the thing about, proving identities is that really there are so many ways to skin a cat, but in this case, you always have to try and get, to the quickest way possible. Otherwise, they can just drag on and on and on. All right, so that is really how the cookie crumbles in this question. The next portion of this question, they say to us, determine the general solution for the values of theta for which the identity is not valid. Write your answer as one single statement. Now remember, in that identity, we had a denominator, right? And in this case, we note that on the left-hand side, our denominator cannot be equal to 0, right? So note in this case that our denominator is tan 2 theta into 1 minus tan squared of theta. So we said tan 2 theta, okay, into 1 minus tan squared of theta, right? In this case, it would not be valid when this is equal to 0, right? So this cannot be equal to 0, ladies and gents. But let's solve for when it is equal to 0 and then make that conclusion. Right, so in this case, that means that tan of 2 theta equal to 0. Okay, in this case, or 1 minus tan square of theta equal to 0. So it would not be valid when that is the case, right? So 2 theta, right, is equal to the arctan of 0, right? Or in this case, tan squared of theta equal to 1. All right, so now if we look at it, so that means that in this case, if we divide by 2 on either side, all right, where is, so that would be 2 theta. The arctan of 0 would be 0, right? So theta would be 0 plus k 180, and where k is an element of integers, right? Or in this case, if we take the square root on both sides, right, tan theta equal to plus or minus 1, right? So in this case, theta arctan of 1, okay, remember that it is plus or minus 1. So I'm going to take both of them there. So that would give me plus or minus 45, right? Plus k 360, right? Arctan of 1, that's 45, and minus 1, that would be minus 45, right? So that's why I've got those two solutions over there, right? Or in this case, I've said, sorry, not k 360, rather, this is 10, so this is k 180. Right, now please, I want you to note, ladies and gents, right, did they give us a restriction there? All right, they said give your answer, or they said determine the general solution, right? So that would be the general solution, right? And where k is an element of integers. All right, so They said we must give the answers as one single statement. All right, I'm not sure what that really means as one single statement. Okay, so it cannot be equal to 0, or it cannot be equal to plus or minus 45. Right, as I said, I'm not really too sure what that one single statement means, but nonetheless, it is what it is. Okay, right, and we move on to the next one. Question 10, they say in the diagram we've got A, C, and D that lie on the circle with center O. Now, ladies and gents, I always say to you when you're doing Euclidean geometry, right, once they talk about a center, for me, the first thing that I'd always do is just go and identify my radii, because I don't know if I will need that, right? So I know that's my center with the radii AO equal to OD, right? And then they say to us AE and DE are tangents to the circle at A and D respectively. So I've got center and radius, tangent and radius there. So that already simply means that those are 90 degrees, right? They tell me that ACD is 68 degrees. So ACD, which is this guy over here, is 68 degrees. And they say that prove that AODE is a cyclic quad. Well, I've kind of already done that. The opposite angles are supplementary, right? So in this case, I'm going to say A1 is equal to 90 degrees. I'm going to say this is the tan perpendicular to radius. And again, in this case, angle D, ODE, angle ODE, right? So that's ODE equal to 90 degrees as well. Again, for the same reason, tan perpendicular to radius, right? So in this case, it means that A1 plus angle ODE, these would be equal to 180 degrees. Of course, it's 90 plus 90. So therefore, AODE is a cyclic quad. All right, so why is that? I'm applying the fact that the converse, right? This is the converse of the opposite angles of a cyclic quad. All right, so that's it right there. And please remember, once it is a cyclic quad, it means that we can actually treat it as such. All right, so the next question, they say determine the angle E. Now, firstly, I'm going to go with O2. O2 is equal to twice angle C, which is ACD, right? ACD, and this is 2 times 68 degrees, right? And why is that? This is angle at center, right? Equal to 2 times the angle at circumference, right? So in this case, that means 2 times 68, that is going to be 136, right? Am I correct? I've been doing this for long now. So, right, that's 136. So now, I know that O2 is 136, but we know that that's a cyclic quad. AODE is a cyclic quad, so that means O2 plus E, right? O2 plus angle E, right? Those would be equal to 180, and these are opposite angles of a cyclic quad, right? And so that means that angle E would be equal to 180 minus the 136, and in this case, right, lazy bones me, so that would be 44 degrees. All right, so that is really how we're going to answer that. All right, let's go to question 11. Now we get into question 11. Right, we are on the money. So they say the equation of the circle with center C is x squared plus y squared minus 12x minus 4y plus p equal to 0. Now they say AO, OB, AB are tangents to the circle, right? And they say that B is the point, 12 and 0. All right, so let's look at the questions that follow. They say determine the value of P. Right, so first of all, they had given us the equation of the circle. So we've got x squared plus y squared. Okay, in fact, let me do this. Let's just rewrite it. Okay, that's x squared minus 12x. Okay, I'm going to leave some space there. And we've got y squared minus 4y. And that's plus p. Okay, and this is equal to 0. Right, so right, so let's first complete the square when it comes to this. And remember, how do we complete the square? We always take our b value, divide that by 2, and we square it, right? So negative 12 over 2, that gives us negative 6, right? And when we square it, we get negative 6. So this is negative 6 squared, which is 36. But I always want to place it there as negative 6 squared. Now we've added something that wasn't part of our equation, right? So I'm going to do so as well on the right hand side. So this is plus negative 6 squared, right? And let's do the same for y. Okay, we're going to take negative 4y. So that's negative 4 over 2 squared. And what does this give us? It will give us negative 2 all squared. So I'm going to add that. Okay, let me just make some space there. So plus p. So this is going to be plus negative 2 squared. But remember, what I do on the left, I will also do on the right. So that's plus negative 2 squared. All right, now let's write it in the form, right? So if we factorize this, this will be x minus 6 all squared, right? That's why we write it in this manner. And this will be y minus 2 all squared. Okay, I'm going to take the p to the other side. This is equal to, so we've got 36 plus 4, which is 40, minus p. Okay, so that means that is our r squared, right? So we now need to find out how are we going to get p from that. So we know we've got the center, and the center of our circle is going to be 6 and 2. All right, now if I just look at that, so that's going to be 6 and 2, that's our center. Okay, and by the way, if I were to draw that center there like this, the radius, you can see that our radius in this case, or rather that y value, would be equal to 2. The distance there would be 2, right? So that would be the radius of our circle. So that means that, and remember this would be r squared, right? So that means that r squared is equal to 40 minus p. And now look at this, ladies and gents. What is our r? Said this is 2, which is 40 minus p. And so now have a look at this. So which will give us, if we take the p to the other side, so p would be 40 minus 4, and this would be 36, right? And so that is our value for P. Okay, so let's just make sure. So we've got r squared, that's 40 minus P. Yeah, definitely P is equal to 36. All right, ladies and gents, that is essentially how we're going to solve that. Okay, right, now let's go to the next question. They say, determine the equation of AB showing all working out. Right. The equation of AB. So we are looking for the equation of that line, right? Now note, ladies and gents, it would be difficult for us to find the points A, okay, with the information that we've got. However, what I can do is, let's find, okay, so if I draw those radii like that, okay, would you agree if I constructed a line CB, right, at least we know the point there is 6 and 2, that's our center of the circle, right? Now, would you agree with me that if I could find the gradient of this line, I'd be able to work out the angle, right, theta? But if you look at those two, okay, let me call this point P, right? If I look at this triangle PCB, right, that, if I call this point Q, it would be similar to triangle CQB, right? Why? First of all, you've got a right angle there, okay? You've got their hypotenuse is common, and you've got another side that is equal, okay? So it would be right angle hypotenuse side there. So those are similar triangles, right? So what does that mean? It means if we could find the angle there, we can also find this angle here. It would also be equal to theta. We can then get the angle, or rather the angle that AB makes with the horizontal, right? And we can then determine the equation. I hope that that makes sense, ladies and gents. So let's look for the gradient BC. Okay, so I'm gonna say, well, the gradient of BC, that's y2 minus y1 over x2 minus x1, right? And our y2, let's say that's going to be 2 minus 0 divided by 6 minus 12. And 6 minus 12. Okay, so that will be 2 over negative 6. And that gives us negative 1 over 3, right? So now that's the line BC that we've constructed. In fact, we should have stated that. Construct BC. Okay, right, now we can find the angle. So the tan of angle theta would be equal to the gradient, and so theta would be the arctan of negative 1 over 3. Right, let's find that quickly. So that's arctan of that negative 1 over 3. All right, so we get negative 18.43. Okay, so that's 18.43. Now remember, the reason why we're getting a negative is because the gradient is negative there. All right, so but what it means is that this angle here is 18.43. But we did say that angle, let's give it a name. So let's say angle CBO, right, would be equal to angle ABC. So CBO, angle CBO is equal to the angle, right? We said ABC, and in this case we can say next question says determine the equation of AB and showing all your working, right? Now I want us to quickly have a look at it, ladies and gents. So if you look at that line, now we would not be able to obtain the line AB through any other means in this case, right? Please, if you have another idea, perhaps just share it with us. But here's my thoughts, right? That if we could find, okay, so these are my radii, right? If I just drew the line CB, which is that line over there, right? So in this case, I would actually divide those two triangles into two similar triangles, right? Why are they similar? Okay, first of all, you've got each one of these would be right angled, right? So these are right angled triangle, that's the 10 radius theorem, right? And the hypotenuse is common, which is CB, right? And in this case, they've got equal sides as well, which are those radii, right? So we know that triangle CB, well, let's call this point Q, let's call this point P. Let's say triangle CPB is similar to triangle CQB, right? All right, so triangle CPB would be similar to triangle CQB. In fact, I should have actually written there, let's construct a line. We said that was line CB, right? So we're constructing CB. And why are these similar? Because of right angle, hypotenuse, and the side there. All right, now what I'm going to do is simply say, ladies and gents, if we can find this angle here, and let's call it theta, right? Because they are similar triangles, it would be similar to that angle there, which is ABC. So triangle, or rather angle CBO, so therefore angle CBO would be equal to angle A. Okay, let's write that nicely. That would be ABC. And in this case, we said these are similar triangles, right? Right, so now we can find the gradient of the line CB. So if I find the gradient of CB, that's y2 minus y1 over x2 minus x1. Remember, we found the center there, and our center had the coordinates, we said 6 and 2. Right, so this guy has coordinates 6 and 2. And so what we can do is find the gradient CB. So that will be 2 minus 0 divided by 6 minus 12, y2 minus y1. Okay, so we said that's 2 minus 0 divided by 6 minus 12. And so that will be equal to 1 over negative 6 in that case, sorry, 2 over negative 6 rather, 2 minus 0, which will be 2, and that's divided by negative 6, which means that our gradient of the line CB is negative 1 over 3. Now we can say, well, the tan of theta is equal to that gradient, that's negative 1 over 3, right? And so theta would be the arctan of negative 1 over 3. And what do we get there? Okay, that's negative 1 divided by 3. Okay, and I get minus 18.43. Okay, let's say that's minus 18.4. So let's just make that 18.4, right? Now remember, we said that angle theta would be equal to the other angle theta over there. So that means angle ABP or ABO. Therefore, angle ABO would be equal to 2 times that 18.4, right? So that would give us, this is 36.8 degrees. Now we can find out the gradient of the line AB. Of the line AB, right? So MAB would be the tangent of, right? So that would be on the negative side there. That's negative 36.8. Okay, so that's the tangent of negative 36.8. Okay, we get 0.7. Okay, let me do this. So that would be a tan of 180 minus 36.8. Yeah, I get the same value as well. Okay, so that would be negative 0.78. Okay, if you don't mind, I'm just going to say this is 0.75. Okay, right, so that's minus 0.75. Okay, I couldn't get that to be a rational value. And now, they said we need to get that equation. I am going to say, right, okay, actually I think something is amiss there. Negative 1 over 3, 0.75, okay, so that would be actually 3 over 4. Right, so that's negative 3 over 4, approximately, right? So, going to say, well, the gradient is negative 3 over 4 x plus c. But remember, what do we have there? We've got those two. It passes through that point 12 and 0. So when x is 12, so y, y is 0 when x is 12. Okay, so 12 times 3 over 4, that would give us, okay, so that would be negative 9, right? C. So therefore C is equal to 9. And if we want that equation, so this will be y is equal to minus 3 over 4x plus 9. All right, now we go to the next portion of the question. Now they say to us a second circle with center 0, 9. So the center of that circle would be 0 and 9. And they say with points 2 and 3. So it has a point 2 and 3. right? They say it lies on the circumference, or rather that lies on the circumference is drawn on the same set of axes. So they say, do the two circles intersect, show all working. Now remember, ladies and gents, when two circles intersect, okay, so let me just draw those two there. Okay, right. How would I know that two circles intersect? Now, when they just manage to touch each other, right, that means that the sum of their radii, right, would be equal to, let's say their centers are AB. So, which means the distance AB from their centers would be equal to the sum of their radii. If that distance becomes smaller than the sum of their radii, then it means they intersect. Now I want you to think about it. If my circles look like this, right, then it means that the distance from their centers would be less than the sum of their radii. But if they don't intersect, okay, so if I've got two circles like this, then it means that their distance, right, would be far from, or rather would be greater than the sum of their radii. Now, here's what we're going to do. I know the radius of the first circle. We said that was 2, right? Let's find out the radius of this circle. So we're going to find that distance there. Okay, so we're going to look for R2. That's going to be the distance. So I'm going to take x2 minus x1. So that would be 2 minus 0 squared. So that's 2 minus 0. Plus we'll have 3 minus 9. Okay, squared. All right, so this is going to be 4, the square root of 4, plus, now 3 minus 9 gives us negative 6, right? And negative 6 squared, that will be 36. Okay, so we get the distance there to be the square root of 40. That's the radius, right? So now, which means R1 plus R2 would be equal to, the first radius was 2, the second one is square root of 40. Now let's add those up. Okay, that's 2 plus the square root of 40. And in this case, we get 8.32 approximately. We get 8.3 units, right? That's the sum of their radii. But now let's find the distance from their centers, right? So their center, the other center. Okay, so let's look for distance between the centers. Right, now what would that distance be? So our center, first center is 0 and 9. The other center of the circle is our previous center, which in this case was 6 and 2. So we've got center 6 and 2. We've got another center which is 0 and 9. Okay, so let's find the distance formula. So the distance in this case between the centers okay, so we're going to say this is going to be x2 minus x1. That's 6 minus 0 all squared. Okay, so we're going to square this. plus. So that's 6 minus 0, and that's 2 minus 9 squared. And in this case, we are going to get, right, so 6 minus 0, that's 36, and 2 minus 9 gives us negative 7, right? And so that will be 49. And so what we get there, the sum of that distance from their centers, that will be square root of 36 plus 49, and that gives us 9.2. Now, ladies and gents, this is approximately 9.2 units. Okay, now remember, which scenario do we have here? We looked for the distance from their centers. It is 9.2, right? But the sum of their radii is 8.3. So it means this is the situation that we find ourselves with, right? That the distance between their centers is greater than the sum of their radii. So therefore, right, as per the question, do the circles intersect? So the answer is the circles will not intersect. Will not intersect. And the reason for that, okay, we said the distance from their centers right, is greater than the sum R1 plus R2, the sum of their radii. Right, ladies and gents, and really that is how this question ends. Let's move on to the next one. To look at question 12. Right, let's go. They say circles with center O, with a diameter AOC and chords AB and BC. Now they say the chords AD and ED and EC intersect at F with OC perpendicular to EC. Right. Now, firstly, let's just look at a few things. We know that we've got center O, so that means that AC would be a diameter. So I would actually just go and show that there. So that means B is 90 degrees. And in this case, I know that a line from center perpendicular to chord, right? Therefore, it means that FC would be equal to EF. Right, now let's look at the next one. They say to us AOC bisects BCE, right? So AOC, so which means that angle C1 must be actually equal to angle C2. We have to keep that in mind, right? But also do note that C1 is equal to D, right? These are angles at same segment, and as well as angle E is equal to angle A1. All right, and of course, angle EFD would be equal to AFC because they're vertically opposite, right? All right, now let's go to the next point. So they say prove that triangle ABC, the big triangle there, okay, is similar to triangle OFC. All right, okay, I can see how they can be similar. Right, now look at the first thing. So we know that angle F1, right, is equal to 90 degrees. That's given. Okay, and that means that also angle B is 90 degrees. Okay, and in this case, because it is the angle at semicircle, right? Remember that AC is a diameter. And then, well, what else do we know? We know that in this case, if we look at C1, so C1, we said this is equal to C2, right? And this was given to us. They said AOC bisects that angle EF, angle EFD, right? I mean EFB rather. Okay, and in fact angle ECB. So in this case, C1 is equals to C2. That was also given to us. So in this case, it would mean that therefore angle O2 would be equal to angle A2. And in that case, that's because it's the third angle on a triangle, right? All right, and so for that reason, therefore, angle ABC, triangle ABC, would be similar to triangle OFC. Right, and in this case, because of angle. All right, very important for us to note that. Now they say determine the numerical value of BC to FC. So what I'm going to do, ladies and gents, I'm just going to do proportionality on those triangles. So I know that AB over OC would be equal to, so that's AB over OC, rather AB over OF. Oh my goodness. Right, AB over OF is equal to BC over FC. Okay, and that's the one that they're interested in. But we know that this is also equal to AC over AC over OC. All right. So they wanted the numerical value of BC to FC. So let's just take a look. Right. So we've got, right, can you see that AC over OC, right? That if we look at that, AC is twice OC, right? And that's because, remember, we've got radii there, they are equal. And so as a result, AC is the diameter, right? So as a result, it means that AC would be 2 times OC. So that means that this is equal to 2 over 1, right? So as a result, it means that if we were to take BC to FC, okay, let's write it in the way that they wanted it. So that's BC to FC. This is equal to 2 is to 1. All right, so there we have it there. Right, now on the next one, they say, hence prove that AC squared, AC over 2 squared minus AB over 2 squared is equals to DF multiplied by FA. Now, usually when we get these, ladies and gents, of course, I think it would be related to what we proved just now, right? But if you look at that, DF is really not in the triangles that we looked at, right? It's in a different triangle. In fact, it's in this triangle, right? So let's find another set of similar triangles, right? And I go back to EFD as well as triangle AFD, right? Can you see that those two triangles are similar, right? So I'm going to say, firstly, we've got F1, rather angle D equal to angle C. That's what we said. So angle D would be equal to angle C. These are angles at same segment. and we've got angle E equal to A1. That's E equal to A1 for the same reason, again, right? Angle at same segment. And in this case, we know that angle EFD and AFC are equal. EFD equal to AFC, right? And in this case, they are vertically opposite angles. Are vertically opposite. And therefore, that means that triangle, so let's see that. So triangle EFD would be equals to, would be similar rather, to AFC. Okay, so triangle EFD is similar to triangle AFC. Very important, ladies and gents, to put the sides that, rather the vertices that are equal, right, to correspond with each other. So in this case, we said this is because of angle, angle, angle yet again. So we're going to use the proportionality theorem again. So I'm going to say EF over AF. This is going to be equal to FD over FC. All right, and this is equal to ED divided by AC. All right, now this is going to be the prop theorem, right? Okay, so in my proof, we've got DF there, which is FD, right? We also have FA, right? So I'm just going to use those ones. So I'm going to multiply, cross multiply there. I'm going to say EF times FC. This is equal to AF, or they said FA, multiplied by FD. Right. Now, in this case, our right-hand side is already proven. Okay, let's write it in the way that they have it there so that you can see it. So we said DF is equal to FA, right? It's the same thing if I say AF and FD. Right, now, please, ladies and gents, let's see. In this case, let's look at EF and FC and try to relate them. Now, if we look at EF and FC, those would be equal. You remember, right? We used Theorem 1, right? If a line drawn from center is perpendicular to a chord, then it bisects the chord, right? So that means that EF is equals to FC, right? But we know that EF is equal to FC, okay? We're going to say line from center, okay, perpendicular to chord. All right, and so that means that I can replace that and say this is going to be FC squared, right? So that means that FC squared is equal to DF times FA. All right, now remember, we already have a relationship with FC to BC, right? Which was this over here. So, but we remember that in this case, it means that BC is 2 times FC, right? So there we go there. So BC is 2 times FC, right? So that means that FC is actually BC over 2, okay? So this guy would be BC over 2, but this is all squared, right? Okay, right, so please keep that in mind. And BC over 2, in fact, let's just write that. We said FC is equal to BC over 2. We had already proven that, okay, in our previous question. All right, I'm actually doing this from a PDF, so you can see how, because I've written so much, it actually keeps trying to save the PDF. All right, so now what we're going to do, ladies and gents, is that I'm just going to replace that there. So which means that BC over 2 squared would be equal to DF times DF times FA. All right, I believe that we are almost there. Now let's look at BC. So BC is in this entire triangle over here, right? So if we look at BC, right, if we look at BC, according to Pythagorean theorem, so we know that BC squared would be equal to AC squared minus AB squared, the square of, now in this case, AC is our hypotenuse, right? So we can replace that there and say, but we know that BC squared is equal to AC squared minus, we said minus, okay, we said minus minus AB squared. Okay, so that is our BC squared. So we can replace that at the top and say, well, we've got BC squared there. So BC squared, and then we can say that's Pythag. All right, I think we've already proven it, ladies and gents. We've really come to the end of this. So that means that this is going to be equal to AC squared. Okay, AC squared minus AB squared. Okay, and in this case, we were going to actually square the 2 at the bottom there. So that's over 4, right? And this is equal to DF times FA. Right, and of course, we can write this right in its square form. So we're going to say AC over 2 squared minus AB over 2 squared is equal to DF times FA. Right, and we have proven that that is definitely the case. Right, I hope that you understood it, ladies and gents. Right, that is really how the cookie crumbles. Now going to go into the next question. We'll look at the last question of this question paper. So they say to us in the diagram below, a house is in the shape of a prism with a triangular shaped roof. They say with one side CN equal to 10, a vertical tree is growing at a point in the garden, and they say NCT is 65, there they are indicated, and CNT is 69, also indicated there. They say the angle of elevation of the top of the tree is 43.5. This is from C, right? So meaning if we were to take that angle there, right? So that angle with C would actually be 43.5. All right, but we'll come back to that. Right, let's quickly have a look at the question. They say, is it possible for the tree to hit the house if it falls? Right, they say show all working. Now, I want you to just think about it, ladies and gents. So we'd need to find out what the height of the tree is, right? So first of all, we need to find that height of the tree, right? Now, if we can find that height, what would be the closest distance in which the tree might fall? Well, I would think that if you take any triangle, right, that would be the longest distance from the vertices, but the shortest would actually be the perpendicular height, right, in that case. So in this case, we're going to have to find out what this distance is here that would form a 90-degree angle with the house, right? Okay, so we'll get back to that. So let's take, firstly, how can we find the height of the tree? Now, okay, let me just remove this so that we don't confuse ourselves. Now, remember we made we said we've got a vertical, we want the vertical height of the tree, and we've got an angle of elevation with CT, right? Now, let's find the length of CT first, okay? In this case, I can do that from the triangle CNT. So in triangle CNT, all right, I can see I don't have this angle just yet. So let's say angle T would be equal to, that's 180. Let's take 180 minus 69 minus 65. And so that would be 46. So that's 46 degrees. And this would simply be the third angle of a triangle. Okay, I'm not going to waste time with that one. Okay, you understand it, ladies and gents. So that means we're going to now use the sine rule. I'm going to say I'm looking for side CT. So CT divided by the sine of the side opposite that. So that's the sine of n is equal to, so CT over sine of n would be equal to Cn. Right, so Cn is the side that's given over the sine of 46 degrees. Right, so to find the value of CT, right, we cross multiply there. That's going to be Cn times sine n. Okay, so we're going to say Cn is 10 times the sine of n. N is 69 divided by the sine of t, which is 46. So sine of 46. Right, so what do we get there? So we're going to say 10 sine of 69 divided by the sine of 46. Okay, I get 12.9. Yeah, we can actually round it off to 13. So I'm just going to make this 13 meters. Right, so the side CT is 13 meters. So let's now find the height of the tree, right? So you remember we said it makes an angle of elevation, right, of 43.5. Okay, so now if we take that as a 90-degree triangle, remember the tree is actually standing vertically, right? So in this case, it means that which sides do we have? We've got the adjacent side. We want the opposite side, right? So which trig ratio would say opposite over adjacent? That would be the tangent, right? That's 10. So the 10 of 43.5. So we are now in triangle ACT. So in triangle ACT, right, we're saying the 10 of the angle of elevation, that's 43.5, would be equal to the opposite side, which is 80, the height of the tree, divided by CT, which is that adjacent side. Okay, so we are looking for 80. So 80 would be equal to CT, the 10 of 43.5. Okay, so what would be that height there? Right, I still have the value, so I might as well just say multiplied by so I'm going to say my answer multiplied by the 10 of 43.5. Okay, I get 12.3. So that would be 12.3, okay, meters. So this is the height of the tree, ladies and gents, right? So now what we want to find out is what is the shortest distance from the tree, okay, to the house. And that's where I said to you, if we can find, okay, this thing is misbehaving now. Okay, if we can find the perpendicular height from that point, right, from the house to that triangle there. So in that case, that vertical height would be the shortest distance from the tree to the house. Okay, right. So now what I can do is, right, I'm just going to do it over here. Okay, let's make some space. Right, so in this case, I'm just simply going to say, right, so I'm looking for the vertical height. So I'm taking this triangle over here, and I'm going to look for that distance there from the house. Okay, I don't know what you want to call this point. You can call it PT, right? So I'm going to say, right, so that's going to be the opposite side, okay? And I've got the hypotenuse, which is CT. And what is opposite over hypotenuse? That would be the cos, right? So which means, opposite over hypotenuse, that's going to be sine. So sine of 65 would be equal to that side PT, which is the height, over, so that's PT divided by the hypotenuse, which is CT. And so that means that side PT would simply be 13, right? So that would be 13, the sine of 65. Right, so that would be the shortest distance from the tree. Okay, so that's 13, the sine of 65. I get 11.78 or 11.8 meters. Right, and so what does that tell us, ladies and gents? Of course, if the tree has a height of 12.3 and the shortest distance is 11.8, then it is definitely possible that the tree will definitely hit the house, right? So therefore, the tree will hit the house, right? Hit the house. All right, and that is essentially how we will answer that question. I hope that it makes sense. All right, ladies and gents, we've reached the end of our video. Please just check the descriptions for if you want to contact us. All right, we are also at the Mlungisi Nkosi Maths and Science Center that's based in Honeydew. You can come through for any assistance in maths and science. All right, and please visit our website www.mlungisinkosi.co.za. All right, from me, your favorite uncle, I hope that you enjoyed this. I'll see you guys again next time. Sharp, sharp.